So we got paint abrasion, and then a thing we call alkali silica reaction, which is when runways are constructed, if there is too much silicon in the aggregate of the concrete mix, it will make short life of that runway. So instead of 25 years on average, like at Detroit, it took it to 15. So all of a sudden there was another $100 million to replace a runway.
How often are you going to remove the rubber deposits? I mean, obviously it's different, but is there like a standard?
Great question. So to remove rubber deposits, first of all, we've got to determine, is there enough rubber on that runway from the landings to actually make it less safe? So how do we do that? We actually go out there and we measure the friction on the runway by having literally a tire with a computer mechanism on an axle drugged behind a pickup truck, and it brakes it so many thousand times a minute and comes up with a reasonable friction reading. And then we actually have to go out there on the average 3 to 4 times a year, depending upon heat, because the warmer the pavement, the more rubber we're going to leave behind. And we have to go out there with an acid to start loosening it up. And then we go out there with those same trucks that take the paint off, and we lift the rubber off and vacuum it up and dispose of it in an ecological way. Yes, you just said it. This lady here just went, yeah, exactly. So some more things, geometry issues. So if we have taxiways that go around the end of the runway, that all of a sudden a pilot could see another aircraft taxiing and abort a takeoff because it was alarming, because it's hard to see 2 miles down the way. Is that aircraft coming onto my runway, or is it on the taxiway that's going around behind it? So we build these visual screens. And then we have to be careful about ramps that exit straight onto runways. And then we also have to look at the angles that intersections of taxiways going onto the runway. So at Detroit right now, we're getting set to do what we call a full depth replacement of runway 27 left. So we're going to take it all the way down to dirt. But in doing that, we're also reevaluating the intersections and the angles of the intersections to see if they comply with the latest guidance from the FAA. That project, with its associated taxiways and repairing the tunnels that go underneath the runway and the taxiways down there, if you've ever driven through that middle service road to get you from terminal to terminal, that's $300 million we're going to spend starting in 2027.
Did you say that that red thing, the red and white, is at the end of every taxiway?
That is between a taxiway that goes around the end of a runway and the runway itself, to block the visual sighting of an aircraft taxiing while an aircraft is trying to take off. We're also, again, have to deal with unmanned aerial systems. We've heard a lot about drones lately now. Either on the airport, off the airport, and unauthorized activity. Detroit has a drone detection system for most of the recently produced drones, that it can pinpoint a drone and the operator within 10 miles of the airport to be intercepted if they're flying their drone inappropriately. They do have drone countermeasures that either disrupt the frequency of drones or literally goes out with other drones, I kid you not, with a big net and fire it at that drone and tie up the computers. However, the FAA is not authorized to do anything about that. That is Department of Defense or Department of Justice. Aircraft de-icing. So as we look at wintertime operations, going out there, if there is visible contaminant, i.e. frost or ice or snow on the wings or fuselage, those aircraft have to be de-iced. So if you're out there and you see this happening while you're at Detroit Metro, you'll see, first of all, normally an orange liquid being sprayed on the plane. And that orange is something that's heated and it helps melt off all that contaminant. It's like a warm antifreeze. Then the second one that they put on there, they put on type 4, which is a green type of fluid. It's gelatinous. And they put that on immediately after they do the orange, and it sticks to the wing. You probably say, well, why are they doing that? Well, now, if it's snowing, the snow keeps accumulating on the plane. The plane has so many minutes of what we call holdover time to get out to the runway and get into a takeoff mode and get into the air. But at approximately 100 knots airspeed, that green gelatinous material shears off of the wings and takes the snow with it, and that's what enables the plane to fly then.
With the stuff they're using right now, what's the contamination of the stuff that's falling on the ground?
Could you say that again?
The stuff that you're using right now, how safe is it after it hits the ground as far as contamination and all that? Is it still a big issue, or?
Well, yes, it is. It's any type of a chemical used out there is always going to be an issue. But it's first of all, it's a chemical that Detroit, #1 airport in the United States for reclamation of de-icing fluid. Literally, they reclaim it through drains, loaded in trucks, and it goes back and is reprocessed. And last year, the airport made about $1 million by just sucking up the old fluid and sending it to recycle and getting a check. If the loads that are happening out there are too much and there's some overflow, then it goes to sanitary treatment plants where they treat it.
And sorry about all the questions. As far as that goes, like some southern airports, like somebody in Florida is almost never going to have any. Orlando, I mean, maybe, I don't know, it might come 32 once a year. They all require, who's required to have this stuff versus, is there like a requirement, or is it just?
It's all dependent on the environmental regulation of the area. So EPA is involved.
Oh, no, I mean, as far as, is Miami Airport required to have de-icing equipment?
Not required, no.
Okay,
Sir,
it's up to everybody.
could we hold the questions till the end of your lecture, please?
Sure. Okay. All right, so airport construction. As we're going ahead and we're constructing, how about we also have to think about the material piles, the big mounds of aggregate that are out there. We have to make sure that those aren't interrupting and providing a hazard to flight. We have to look at the equipment that's out there, the personnel, the dirt and dust. Are the personnel trained to actually be out there and not all of a sudden get somewhere where they shouldn't be and interrupt the safety of the planes? Dirt and dust, same way on the engines. And again, airport construction, interaction with other systems and construction standards. If you look at this, this is what we call a ground run-up enclosure. This was also built down in Detroit. They have them at various airports and everything, but when an aircraft is done with engine maintenance, a lot of times they need to run it up with full throttle, which creates a lot of noise. And this building here that you see is a U-shaped building with sound absorption panels on it, and the fact that the U shape points towards the least obtrusive area around the airport as far as residential noise. So it actually points south at Detroit, down where there is less inhabitants, to help lower that noise issue with them. And if you look, you'll see that the side of this building on the outside has a reverse angle from how you would normally see siding on a house. Typically, lap siding on a house overlaps at another angle. This laps down. Anybody want to speculate why? Because of the radar energy coming off the radar antennas at the airport, instead of it being reflected back and providing false signals, it takes the radar energy and drives it into the ground. So as we talk about, are we cleared for takeoff? These are some of the things that are all going into that consideration. And now let's talk about the pilots, the certifications, what training they have there, and medical qualifications. We hear a lot about that. We hear a lot lately as we start talking about the Air India crash. Were they mentally fit? Did that contribute to Air India's crash with all of a sudden shutting fuel off? So we've got issues there we've got to think about. And then, of course, the aircraft, the design, the manufacture, how it's maintained, and what's the service life on it. Here's the latest environmentally friendly aircraft design. Renewable fuel and less noise, except for the squawking. Now let's talk about air traffic control itself. For those curious, this is Kalamazoo. This is the new air traffic control tower at Kalamazoo, plus the approach control for southern Michigan. For those that don't know, we used to have radar systems for controllers at Muskegon, Grand Rapids, Kalamazoo, Lansing, Flint, and Saginaw that used to control all of southern Michigan except for Detroit. They got rid of all of those, what we call TRACONs, terminal radar controls, combined it all up into Kalamazoo, and it is now called Great Lakes Approach. So how many facilities are we talking about? Air traffic control towers. There's 263 federal control towers, 262 contract. Those are typically the lower level, the lower activity facilities. And for reference, Marquette has one of those. Battle Creek has one of those. Detroit City Airport, Jackson, Michigan. Versus the federal ones are Muskegon, Traverse City, Saginaw, those types. So 521 total air traffic control towers. And then terminal radar approach controls. This is like this facility that I was just telling you about in Kalamazoo. This facility here is Detroit. There's 25 standalone, what we call standalone TRACONs. And then 121 combined with an air traffic control tower somehow, for 146 of those. And then around the country, we have these huge facilities. There's 26 of them total that usually work all the airspace up high, typically from 10 to 23,000 and on up, all the way up to around 60,000. And for instance, one of these is based down in Cleveland, one's based in Minneapolis, one's based in Chicago, one's based in Indianapolis. So they handle a lot of all this traffic once you get up high and you're just cruising along in the plane with the pilot doing his thing. These are the type of controllers that are doing that type of work. So, and again, just like the pilots, certifications, medical qualifications that we need to think about, and the training that goes with it. We've heard a lot in the news lately about training new air traffic controllers and how backed up the system is. We need X amount of controllers to get the system back to normal. Well, all that takes lots of time, and here's why. So the initial qualification training is done down in Oklahoma City. And we do the initial qual plus we do radar training down there. But then continued training, once we get them out into the field, we've got proficiency. We've got to make sure we're keeping up with everything that we should be doing, new procedures, and then anything for enhanced training. These are some of my controllers at Burlington, Vermont, standing in front of one of the Burlington F-16s. And then classroom training. We got to talk to them. We got to teach them the operating rules, the separation standards, navigation, airspace, aircraft recognition, aircraft capabilities, and of course, weather. And some of the standards. You look at this and you go, my gosh, this is a cartoon. But this is actually out of the out of the controller's handbook called the 7110.65, the order. And this is actually how to measure aircraft that are departing and when you can actually let them to the next one go. It's as simple as this in a lot of cases. But then we're also talking to them about airspace. For those that aren't familiar with it and everything, here's Charlevoix's airport, Lake Charlevoix here. But all of this means something. This symbol tells us what type of airport it is. This magenta outline tells us that this is Class E airspace inside here. But we've got A, B, C, D, E, and G airspaces. We have military operations area, restricted areas, prohibited areas. Who can name a good prohibited area? This should be easy for everyone. White House. You bet. You bet. And then, of course, warning areas. And then we also have to talk to them about terrain and obstructions. So in designing the system, remember that we're designing really two things out there. One is the pilot that goes out there just like you would drive down a road. And you're going to go drive down the road and you're going to visually see where you are. And every now and then you're going to look at your phone and say, I didn't think I needed to go that way, but that's the way I'm going to go. And then the other way is that the pilots are going to operate solely on their instruments. And they're going to be reassured that the procedures that we have developed are going to keep them from hitting terrain and hitting obstacles. And we're going to give them an organized way to either get off the runway and get up to altitude without hitting something, or an organized way of getting from altitude down to the runway without hitting something. And what I've got up here, this is a typical procedure. This is called the RNAV GPS runway 27 at Charlevoix, Michigan. And here's Charlevoix on this map. But these are all the points that a pilot's going to use to get into Charlevoix easy. And right here, this angled portion that takes us down to the ground, that's the path, the vertical path that pilot is going to use to guide his plane down. So all this stuff is proceduralized to protect the pilots and you from actually hitting anything on the ground before they can actually visually see the runway right at the end. Again, classroom training, computer entries, phraseology, airspace again, operational procedures. and then national security and VIP movement. I tell you, the election season is a gargantuan headache with the presidential movement around. This is actually Detroit, and if you notice, coming off of this plane right here is a helicopter. They basically bring multiple things in like this with the helicopters, with the limousines, the Secret Service cars that go to protect the individuals. So it's quite a big deal. And then back to the airport again. We're talking about airport signs, markings, measurements. How long is the runway? How wide are the taxiways? All of this controllers need to know, including those published approaches that we just talked about coming into Charlevoix. Now this is the approach lights coming into a runway, and they're working on developing a new system now to make sure that pilots land where they should be. And this is pretty high tech and everything, so bear with me. Oops. Can you go back? No, now it's not wanting to work. Well, I'm sorry. It was supposed to be something funny, but it's not because it doesn't work. Okay. As we talk about airport features again, we need to still talk about de-icing areas. How many aircraft can fit in there? What are the widths of them? Are they going to interrupt or hit each other? And then airport emergencies. Every 3 years, a commercial airport has to do a full emergency practice out on the field where local agencies respond. And in this case, this was actually done during COVID. Typically, we would put real people out on the pavement with tags on them saying, hey, here's my injuries. And they would actually the emergency people would have to triage and decide who was going first, who was going second. In this case, we used blow up dummies like that. And there is the little tag right there that says, hello, I have these injuries, please act accordingly. And then the Airport Response Center and the Emergency Communications Center get into the action too and have to know their roles in trying to keep everything safe. As we talk about snow removal, airport equipment and procedures, typically this is called a multifunction vehicle for removing snow. If you look at that plow blade, that is 22 feet wide. So when you think about that with your average road plow, this actually covers a full lane plus another 10 feet. That's how wide it is. Then behind, in the middle portion here, is a broom. And just like the plow that you can angle, the broom can angle. And so this is getting the majority of the snow off. This is getting the little bits. And then behind there is a big, think of a backpack blower on steroids that takes any of the chunks that are left over and pushes those over into the next lane where the next machine, just like this, is coming down the road. And it looks like that. And at Detroit, there are 39 of these machines to work the snow, as well as blowers, as well as other associated equipment. So as we still talk about controllers and on-the-job training and everything, you may have heard this in the news this past 6 months. Oh my gosh, the controllers are still using pieces of paper to track planes. And yes, they still do. And yes, it's actually still a pretty good system. And believe it or not, so as we look at, we'll say this aircraft here, Delta 2503, the controller knows that that's a Boeing 757-200 series. The Q tells us what type of navigational equipment they have on board. The 515 is just a quick strip number that we can associate with this to make changes. 5763 is a number that the pilots dial into a transponder in the plane so air traffic can track them easily. Then we have P1754, means they're proposed to take off at 1745 universal coordinated time. We don't use local time, because now every time everything changes on daylight savings time, we're not going to reorganize the whole system. So everything runs on universal coordinated time, or Greenwich Mean Time. This aircraft is requesting 39,000 feet. We dropped the last several zeros. And it's going from Detroit Metro, DTW, and it's going to land at FLL, which is Fort Lauderdale. And this is the route in between, so the air traffic controllers know where they're going. So this looks like, oh my gosh, this is dark ages. You know, it's really not. What's dark ages sometimes is if the tower controllers are writing on this piece of paper. And in many control towers now, to get that down to the controllers in the radar room, they drop it down a piece of irrigation hose that goes down there and lands next to the radar controller, and they go, oh, another departure. Here it is. So, it's kind of antiquated, but it works. They use a system in the towers, many of the towers, called SDX, Airport Surface Detection Equipment Model X, which helps track the aircraft on the ground. And the beauty part about this is it also helps prevent collisions and warns controllers when there is the possibility of a collision. That's what it looks like in the tower. And coupled with that is another system we call runway status lights, RWSL. And it's a series of sequenced lights that tell a landing or departing aircraft when it's clear, or a taxiing aircraft when it's clear or not clear. So this is how it works. So we're approaching, there were no lights in the landing area, so the lander knows that he's ready, he's good to go. Now, he's getting ready to go, but somebody's crossing. So there's lights that flash in the middle of the runway until this one gets clear. Boom, there goes the lights. He knows now that he's cleared, even though that's what the controller already told him. Likewise, this one's approaching the runway, and they had lights that were showing, no, don't go out here. But now he's going to go ahead, he's going to get out here, and you'll see where the lights come on and come off. Wow, he went through, okay, he's going through, now everybody's got a red light. They're telling everybody to stop. Pretty sophisticated system, all in-ground lights, all run by computers and everything, all off that same system that I just told you about called SDX. Again, with classroom training with the controllers, knowing what some of the capabilities are and what the equipment is, we have this odd looking piece of equipment called a VOR, very high frequency omnidirectional ranging system. For anybody that's been down near Empire, Michigan, there's one in Empire. There's another one up by Pellston. These are ground-based units and everything that provide guidance to planes in the air. And then we have the radar antennas themselves that we look at for how they're used, what their capabilities are. And then the radar system called STARS, stands for Standard Terminal Automation Replacement System. And then we have another piece of it called Tower Situational Display, TSD. This basically is what it looks like. And if you're wondering, hey, what's all this colored stuff here? That's actually weather. That's how we display weather on those. And you'll see different shades, plus then you'll see different symbology that shows some of the heavier cells. Here's typical of all of the displays that happen up in the tower. Looks pretty cool at night. And then we've got what it looks like in the TRACON, the terminal radar control area again. Now we're gonna show you something now. This is Detroit. Detroit's in the center. To kind of give you some scale, this circle is 40 miles from Detroit. So the dotted lines that you see right here are the final approach courses. This one here is for runway 22 right. This one right here is for runway 21 left. And I'm going to start a traffic replay here so you can go ahead. Now these are arrivals coming into Detroit. And this is what it looks like, sort of, for the controllers. And you can see right here, that S symbol stands for what controller is working that at the time. Delta 966, here he is a DC-9. He's gonna land runway 22 right. And right now, still doing 396 knots. Across the ground. Get this back to where it needs to go. So here's the arrival, what we're looking at with the arrivals. Now, everybody knows that an airport just doesn't have planes come to it. They also have to leave. Now that's what it looks like when everyone's starting to come and leave at the same time. But you know, we haven't accounted for everything yet. We also have to think about, well, what about all the other airports around Detroit? Detroit City, Pontiac, Willow Run, Ann Arbor. So by gosh, by golly. Now we're going to add all those. And that's a typical display at Detroit during an inbound and outbound push right there. So adding to all that, you saw that other radar antenna that we had. This is also a radar antenna, a long-range radar antenna. This typically picks up aircraft that are as far out as 200 miles from this, and then feeds the information into the system to display that aircraft accurately on its position on the scopes. So, as we talk about training controllers, we're going to talk about, okay, we've always heard about a lot of stress and all of the things that they have to follow at the same time. So I have a challenge for everybody here. If you've seen this before, please don't comment. Just let other people take it in. But I'm going to show you some students that are out there in this one room, and they're handling a basketball. And they're passing it to each other. And some of them are passing it straight, right to the next person. Others are bouncing it on the ground first to that person. So what I want you to do is I want you to count the bounce passes. Okay? So, here we go. Okay. Who wants to give me a number?
14.
7,
13,
14.
9,
14.
7.
7,
14.
14? Okay. You can see, first of all, kind of a challenge. Okay? Just like controllers, lots of things going on that we got to sort through visually, mentally. All right, but now, how many people saw the gorilla?
Did they ask, did he come from the government?
So, let's look at it again. For those that didn't see the gorilla. So what's the point we're trying to make here?
You have to focus.
What was it?
You have to focus.
Focus? But focus on what? All of it. So, you know, when we first started using this to show people this and everything, I kid you not, I was talking to 300 state of Indiana airport operators. And I did this video, and I said, how many people saw the gorilla? And I kid you not, 4. 4. They were so intense, so focused on the assignment that I gave them. Fly the plane. Keep these aircraft separated. But they lost focus on the bigger picture, which is intrinsic to pilots to air traffic controllers, and all of a sudden, things can get away from you and get surprised by it. So as we talk about controller staffing, here we are talking about controller staffing, which I'm sure everybody's heard ever since the unfortunate incident in DCA earlier this year. Right now, we see numbers like the FAA is 3,000 people short for controllers. But there is no magic formula for just hiring them and getting them in place. As you saw with all this training can take anywhere from a year up to 4 years, depending upon the facility that they go to, how much knowledge they have coming through the door. And so it's challenging. So there is no magic solution. And how many here remember Ronald Reagan firing all the controllers? Okay. I was a product of Ronald Reagan's rehiring program. And that was in 1981. We went almost a decade before we started feeling normal. So what we're faced with challenge-wise today, very similar situation. It just doesn't happen overnight. We just can't go hire more of these people and expect them to start working planes. So the other thing that's playing a cruel joke on us is now that we're short, now we're also having people work a lot of overtime, which is creating more stress, which is tiring out the workforce. So we've got problems there. And then we have the fatigue of working shift work. So typically, I'm going to give you an example of a shift rotation. When I was working at Lansing, I could typically come in on whatever my first day of the week was, and 3 o'clock in the afternoon is when I'd start and work till 11 o'clock that night. Then the next day I would come in and I'd work 2 in the afternoon till 10 o'clock at night. And then swing back around and come back in at 8 o'clock in the morning and work till 4 o'clock in the afternoon. And then come in the next day and work 6 o'clock in the morning until 2 o'clock in the afternoon. Go home, take a long nap, come back in at 10:30 that night and work till 6:30 in the morning. And that was a very common schedule that we used to work. Now they have fatigue time off between shifts where they've increased that spacing a number of hours between shifts. But now they've created other problems with doing that and everything. So now with the problem that we started to try and solve, we didn't quite solve it yet. We're getting there. So all these things that we just went over, all those things make the system safe.
Safer.
Safer. Very good. Very good. So let's look at pilot awareness here again. So this is being filmed from the back seat of a small plane, and they're coming in to land. Let's see. You see the guy's hand go, damn it. All that crunching, grinding noise that you just heard,
Tires.
that was the landing gear that never came down.
Oh.
That beeping that you heard
Yeah.
throughout that whole clip, that was the airplane system trying to tell the pilots that the gear wasn't down yet. So as we talk about focus and how we could be concentrating on one thing and totally missing another. Great example. So controller awareness, it happens at small airports. It happens at big airports. So let's take a look at O'Hare. So this was an incident that I investigated years ago at O'Hare on July 26, 2006. It's involving United 1015, a Boeing 737-300. And the call sign is GTI, we call Giant 6972, who was a Boeing 747. And we'll look at the narrative here. So the controller issued a landing clearance to Giant 6972, a Boeing 737, 9 miles out for runway 14 right. CPC then instructed United 1015, a 737, to taxi into position and hold runway 27 left. United 1015 requested and received a 2-minute delay before takeoff. And we'll see what happens here. So here's United taking off. Just told this guy to go sit on the runway, get ready. Giant's out here on final. United's gonna let him know when he's ready. He's looking at weather on his weather radar. It's about 10 o'clock at night at O'Hare. Things are slowing down. Think of all the time that's going by right now. Here comes Giant, the 747, landing 14 right now. He's gonna go park down here. So Giant's slowing down because he knows he's gonna go park over here. United's been cleared for takeoff.
Jeez. That's a mistake.
Don't worry about it.
Don't worry about it. Jeez.
So 25 to 75 feet vertically. When I talked to the pilot of that United that was taking off, he actually pulled it back to start gaining altitude 10 knots before he even should have. So that's what saved him. He saw out of the corner of his eye, saw the 747 coming into view. Yeah, big eyeballs. Yes.
Out of that little itty bitty window.
Why did the air traffic controllers see that?
Awareness, focus, was distracted doing other things, which could have been anything from getting a cup of coffee because it was slow, to reading something that he needed to read, from an operational
Like
standpoint.
maybe the piece of paper that was sent to him.
Maybe the piece of paper crinkled up and he didn't get down the tube.
I've got a question about that.
Yes, ma'am.
So no lights in the runway that would have alerted them to stop?
Before that system was invented.
Okay.
Yep.
System not.
Yeah. So likewise at Detroit, here's another one. So how many people have flown out of the Delta main concourse terminal, Terminal A? Okay. So Terminal A, to help you out with where we are, Terminal A is right here. And then the new Evans terminal is up here. Detroit. And this is Detroit. Okay. Now, using that system that I described earlier, the ASDX, the ground vehicle operations, which we call Operations 373, had requested to go do a runway check that they have to do periodically to make sure the runways are clear, there's no debris on it, anything like that. So he's going to get on the runway here and start heading this way eventually. Now, this aircraft here, flagship 3860, is taxiing out to go to the approach end of this runway and eventually get clearance for takeoff to come this way. Let's complicate the plot a little bit. So how many people heard on the DCA crash that positions were combined, that the controller was working two positions? Okay? In similar fashion, as this was slowing down, and this is slow for Detroit, that the one controller that typically works this side of the airport needed to take a break. And so they were shifting all the functions over to the controller that also was working this side of the airport. Okay? Now, if you look, this typically is a departure runway right here, and there is 1, 2, 3, 4, 5 or more aircraft lined up here waiting to go. So he's trying to also get those out. So now we've got where we're trying to combine positions with another controller. We've got somebody going out onto our runway, somebody getting to an end of a runway where they're going to call, hey, we're ready to go. And here's how the system. Come on. Excuse me. Well, you plan for all the automation. There we go. So you see ops 373 turned to head over to the start of the runway because we don't start runway checks in the middle of a runway. And for those that are wondering, this is during the daytime. Now, as we get up and we get a little further into the video, I'll tell you when, but you'll notice that this side of the screen is actually an enlarged portion of this area. So we're going to shift our viewpoint up to here in just a little bit. Typically during the runway check, these vehicles are moving 30 to 40 miles an hour. And the attention of the driver is on the runway surface for the most part, looking for problems with the surface, not necessarily looking down the runway. You notice the controller told this guy to go get on the runway. And now he's cleared him for takeoff. And now the system is starting to alarm. And it's giving an audible, runway occupied.
That's
In the tower.
not on the planes, but it's just in the tower. Right?
In the tower, correct. So he turned off
Oh my gosh.
just as that guy went by,
Is he alone in that car or is he have somebody else?
typically alone.
That's not smart.
It's,
Especially if you look at just down.
yeah,
Somebody, his partner, should be looking straight ahead.
it's an idea. So anyway, one of the things that I wanted to show you is not only that incident, but you'll also see little green dashed lines here. And that's the computer. As planes are starting to get close to each other, the computer is marking the intersections of what it's actually trying to protect and trying to predict if there will be an aircraft and a vehicle or an aircraft and an aircraft coming together on that runway. So that was Detroit. So let's go back to safety. And let's think about this a little bit. So we had several definitions of how we thought, would work for us with a safe. But now we don't just think about safety and term it like that. To us in the FAA and in the airport worlds, it's all about risk. To understand how risk is calculated. So typically, we look at, okay, as we look at a change in the system or an event, we say, what is the most reasonable result that can happen here? What is it? Is it the most reasonable person would say, everybody's gonna die? Or is it, hey, we might have two planes getting close? Or is it reasonable to say that, no, this really isn't a problem? So as we look at that, we say, hey, how reasonably severe is the outcome of what's going to happen? Is it minimal, minor, major, hazardous, or catastrophic? Now, this is a very tough thing to get across to people, especially air traffic controllers, because I'll tell you, I used to teach this to air traffic controllers, and they would look at typical air traffic controller as everything's safe, everything's safe, everything's safe. Oh, everybody died. There is little in between that final jump, but realistically, there always is. As we look at, let's talk about the DCA crash a little bit. Lots of things happening in the DCA crash. We're operating at night. We're operating on crossing runways. We're operating with a helicopter procedure that is taking the helicopter underneath an arrival. We're talking about a plane on final that is literally in a turn, trying to line up for the runway, trying to judge their altitude, looking at lights that are trying to give them visual signals of what altitude and glide path they're on, and they're turning away from the traffic that they don't even know about yet. So lots of things that are happening in there that now is taking it at any one of these things, not that much risk. But now as we start adding them all together, we say, oh, hey, yeah, this really could be something. And then we measure, hey, what are the possibilities? We try to put it in a quantitative term. And then we see where these two things come together. So if it's remote, less than once per 3 months or at least once per 3 years, but it's a major hazard, okay, well, we're in a medium risk level here. Or if we did it another way, it could be in a low, or the risk level is just too high. And so what we try to do is we try to mitigate how these things are influenced. We can't mitigate the severity. It is what it is. The only thing we can mitigate is the chances of it occurring. And that's what drives risk down then. Okay, so we just went through a lot. We've got all the things that are going into all these decisions every day. And now we're talking about safety and we're talking about risk. So now, does anybody want to give me a definition now of what they think safe is? And then I'll give you the one that the FAA typically uses.
Don't fly.
What's that?
Limiting risk,
Limiting risk?
limiting risk as much as possible.
Take the
Okay.
train,
What's that?
take the train.
Take the train.
An acceptable level of risk.
Did you cheat? Did you know?
You were leading me there.
Give this guy a dinner somewhere. So yeah, we look at it and we say, freedom from unacceptable risk. Because there's all kinds of things out there. What are we going to accept and what are we not? You know, when you're up here in the winter and you say, you know, today I'm going to leave Charlevoix and I'm going to go to Meyer up in Petoskey. Okay? But last night, we had an ice storm. And so now the roads are ice covered. And oh, by the way, we could get up there and maybe the store's not even open because of the ice. Is this sound familiar?
Yeah.
Okay. So all those things that go into it, and we say, you know what? It's not worth it. It's not acceptable today to do this. Maybe on another day it will be. Same thought process, just bigger picture. So why is safety so important? What's that?
A lot of
Save lives?
A lot of lives involved.
That. So, by the way, this is myself and my associates. I'm in the pink shirt. This was after we finished rebuilding another runway at Detroit, runway 21 right. Anyway, these people, this is who we're talking about. This is why safety is so important. So as we think about air traffic controllers and pilots and airport operators and the people that are plowing the snow and people that are getting the fuel trucks out there, and we're thinking about, hey, how do all these things happen? This is the challenge of air traffic control and everybody else. So, so that video is actually made for controllers, but it's about everybody in the system, really. So, yes, sir.
First, I want to thank you for a very informative presentation. It's something you started to get into, but you didn't really name it in terms of safety, and that's politics.
Yes.
Because the helicopter airplane crash killed a lot of people in Newark. And when they investigated that whole thing, they found what you did address about those spitting out paper computers. Now, The Secretary of Transportation the last 4 years was a former mayor of South Bend. He had no knowledge or experience of airplane transportation or any other kinds of transportation, but it was a political appointment. That outdated computer system in Newark, which you seem to find okay, it goes back to the 1980s to have computers spitting out paper. That's ridiculous. They have computers that can replace that. And he went 4 years and never addressed updating any equipment, at least in the Newark airport.
So let's talk about it. So first of all, we're done with the normal program. So let's talk about what's happening right now, okay? So the system, the air traffic control system has been breaking for a long time. Not just with staffing, but equipment. And if you go back into the history, there was an effort in the late 80s into the early 90s to convert over to a system we call Next Gen. Okay? Next Gen is not a magic fix. It was a bunch of components that were under development that said, hey, we're going to try and improve the system with all these different aspects. Okay? Congress funded that, but funded it minimally, and this is under multiple administrations, okay? So the reality is that this is not a failure of a previous administration, a instead of many, and it's not the failure of a DOT secretary that didn't push hard enough. It's a failure of all of the components, Congress, the executive branch, of all these things coming together and nothing really getting done in a timely fashion. Now, here's the ridiculous part of what we're talking about right now, is Secretary of Transportation came out a couple months ago and said, we're gonna fix the air traffic control system in 3 years. Now, that is the mark of somebody that doesn't understand the system also. Because I guarantee you, for somebody who has worked in multiple facilities, has worked in what we call P&R, plans and requirements, that's all the equipment stuff and everything, changing equipment out and stuff and everything, that I guarantee you in 3 years, we won't even have the engineering done that spends the $14.5 billion that was just recently allocated. That's the reality of the situation. Because here's the problem. It's like going down the road, driving 55 miles an hour, and trying to change a flat tire on your car. You can't just stop this system. It's all about changing slowly in steps, very calculated steps, and doing it with safety risk management to understand, hey, here's what we're trying to do. Are we leading ourselves down the primrose path to a disaster? Now, is that a problem? Absolutely, it's a problem. We can't get it done fast enough. But I can guarantee you that it's not just the previous administration or the DOT secretary. This dates back 2 decades, multiple administrations, and how Congress, what happens every year around October? Yeah, we take vacation, but the budget. So for years and years and years, how have we done the budget? All the way down to the last thing, oh, well, we still can't decide. We're gonna go on a continuing resolution. So now everything pulls back to 80% of what it typically would be. So now everything that's in the works, oh, slow down, wait for the money to come in. And part of the problem with procurement is the fact that it's so often done in year segments. We design it to pay for X amount of it, but we only get so much dollars to actually implement it every year. Now, what's different this time is they just approved $14.5 billion. This is outside of the normal fiscal funding that Congress does. So now there's actually a reasonable chance that we get something substantive done. Yes, sir.
So NAV Canada is a private company, right?
Yes, it is.
How good are they? How efficient? How technologically advanced are they versus our system?
I think NAV Canada does very good with what they have, but they do not have the sheer amount of infrastructure that the FAA tries to support. Realistically, if I had to take a rough guess, I'd say less than half. Less than half of the airports, less than half of the infrastructure, the computers and everything. Now, what do? They charge, so their funding streams are more consistent. So it's a possibility, yes.
And how's AI gonna affect all this?
Oh, God only knows. But I'll tell you, so first of all, so take a look at the three people right there. If you notice the guy with his hand up, that's me. The guy next to me, that's my brother, also an air traffic controller. The guy next to him, that's my nephew, also an air traffic controller. My son is also an air traffic controller. And my wife was an air traffic controller. Okay,
And
so we're into the system, I'll tell you.
Why did you want to be an air traffic controller? You like challenges, obviously.
First question first.
So it really boils down to that, is there a possibility for a different way of doing business? Yes. Do I see privatization? Do I see that being better? To be honest with you, absolutely not. Because you can't support the infrastructure that we have. If you want to fix the problem, you can't support it with a fee-based schedule in the United States because it's just so much money, it really can't be supported like that. That's my own opinion. So, yes, ma'am.
Again, thank you so much for a beautiful, clear, concise, enthusiastic presentation. I learned so much. I would like to ask a little bit about the systems that are in place to trigger investigations on near misses like the one you did at O'Hare. So obviously, if there's an accident, that's a little more obvious. But when that situation happened at O'Hare, is there a system in place that triggers we had a near miss? Or does somebody have to be honest about it in the control room, the control tower, or a pilot? How did that O'Hare investigation get triggered? What's there to reassure the public that there's good systems in place?
So first of all, it used to be that a lot of the investigations were triggered because of people verbally saying something, okay? Whether that be a controller, whether that be a pilot. Now that's how it was mostly done decades ago. And you might imagine that, as a controller, you most certainly didn't necessarily want to rat yourself out, okay? And then if you try to rat out your buddy, that was another problem in itself, all right? So the system itself was flawed in that. So then who came along? The airlines came along, and this was the same problem in the airlines with the pilots too. The airlines first came along right after the turn of the century in the 2002-2004 timeframe, and they came up with a non-punitive reporting system with the pilots, okay? And it was an Airline Safety Action Program. Okay, so a pilot could actually report something that really concerned them. Hey, I was a bonehead, I did this. And now you're getting data that says, hey, we've got events out there. Is there commonality with other events? So now we're finally getting enough data All right. Now, finally, air traffic joined in on this whole thing. So we've got air traffic safety action program. But now, so you got those things now that are working for it and everything, but then you also have automated things that are happening. Every time an alarm is triggered, like on that equipment, there is we'll say in the tower cab, there is a order, a directive that says, under these conditions, these type of events, you have to start what's called an MOR, a mandatory occurrence reporting. Basically a form that you fill out, and I mean, as soon as you hit send, oh, everybody in the world knows. I can tell you that as a manager at Detroit, one of my controllers in the tower hit send, and the guy in charge of airports in Chicago called me, and I didn't even know what had happened yet. So you got that system that's out there that says, hey, under these prescribed conditions, you have to do a report. You have automation that automatically reports, hey, we had 2 aircraft get too close. So the automation now is also taking care of that. So you have controllers that are saying, yes, I'm going to report this because I'm not worried about my job. I want to make the system better. You have the automation taking care of it. Plus then you have the system that's in place that says for anything that happens like this, you better be reporting it, because if you don't, that's actually when your job is in trouble.
What happened to the controller in Chicago in that situation?
Honestly, I don't know.
I mean, is that a firing, what do you want to call it? Is that a
Typically, a controller would not be fired for anything that has to do with that, including the DCA crash, because they did not do it with malice. That's the difference. Yes?
Now that we think we've got funding, sounds like, for X amount of time to build a new system potentially over the next 10 years or so, will we look at other nations' systems to see best in class and incorporate some of that, do you think?
Well, it's interesting. So let me tell you how some of this goes. So first of all, $14.5 billion, I guarantee you, is a wink of the funding amount that it will take. Okay, it's huge according to what we have done in the past 2 decades. It is not huge in the total, how is it going to affect the system? We need constant influx of $14.5 billion year after year after year to finally get a handle on a lot of this stuff. Now, and I'm sorry, because I just lost the end of your other question.
Best practices from other countries.
So best practices from other countries. So yes, there are countries out there that have some pretty great equipment. The controllers over in Europe got some pretty cool stuff. But I'll tell you, here's the difference. Typically in the procurement cycle in the FAA, they start with, hey, we think it's a good idea to have a piece of equipment that does this. So then they say, okay, here's some money, go forth and design it. So they hire a contractor that goes forth and designs it. Then the contractor comes back and says, here it is. And then the government says, we kind of changed our mind a little bit. We want you to add this, and this, okay? So the contractor says, okay, walks away, does its thing, comes back and says, ugh, okay? And we go, hey, that's pretty good. We like that, okay? And then we say, okay, how much? And the contractor goes, okay? And then all of a sudden we go, ugh. So now we say, oh, and we got to take some of that away. So we go back, redesign it, go back again. And so this is a vicious cycle. Okay, so by the time we actually get some equipment out there, first of all, it's already outdated. We can't get it out there fast enough. Now, what other countries do is they buy off-the-shelf equipment from Honeywell, from Census. that design these systems already for other countries. We just have to learn to be satisfied with that stuff. Right? Yes, sir, in the yellow, you had a question.
My compliments to you and your fellow controllers from the perspective of a private pilot of 45 years. Out of ONZ, Grosjean,
Uh-huh.
flying Grosjean to Charleroi, back and forth, all the time through Detroit Metro airspace. Fantastic.
A lot of my friends, Detroit, Flint, Saginaw, Minneapolis Center, you bet.
Fantastic group of professionals.
Yes, ma'am.
I want to bring it home to Charleroi Airport. I'm concerned about the parachutists
Uh-huh.
that dropped onto the runway.
Yep.
Or over the runway. And we've got a lot of jets coming in, especially in the summertime. How in the world do they regulate that? And why can't they land way over there?
We, first of all, there's something that goes, there's a system called a NOTAM system, which puts out information real time on things that are happening in the system, outages, procedures, etc. And anytime that the parachuters go up, if they don't have a predetermined document that says we go out on these days at these times, then they typically file a NOTAM like this. Okay, so there is a way that other pilots get that information if they're diligent. Okay, but you know, I can tell you down in the Detroit area with parachute activities out of Tecumseh, I can tell you a lot of times that a couple of those people just damn near wound up on the hood of a 737. So yeah, it's not perfect. And I attribute some of it to what we call the big sky theory, which is the sky's big enough to where everybody should probably miss each other mostly. So.
And what about the grass landing, when they land on the grass runway? And they're going into the wind. I go to the dog park every day, so I see all this stuff. And so they land on the grass runway. I've only seen McPhillips Island Airways do this. And they land into the wind, and the other guys are going, whoa, and they're trying to land on the other one.
Well, personally, I don't jump out of a plane. Now, I will say, I pointed out my aircraft.
But they cross the runway when they're landing on the grass runway. They cross the cement runway
I can see that.
and then cut in.
So my plane has a parachute, believe it or not. So I own what's called a Cirrus, and my wife told me, quote unquote, that if I was going to buy a plane, that was the only plane she would agree to. And so literally, if things go really bad, I can actually reach up right above me here and pull a lever down, and it ejects a parachute that will actually bring the whole plane down for a landing. It's not something I strap on my back. It is the whole plane. So, although I don't believe in anybody jumping out of a plane with a parachute, I sure believe in a plane having a parachute.
So is there an air traffic controller at Charleroi?
No, there is not.
Have you used it? Have you done the parachute?
No, you know, if you pull that handle, it basically, when you come down, you are going to destroy the plane. Now, as far as I'm concerned, that's why you buy insurance. Yes, ma'am.
And what's with the Muskegon Airport? When my son lived in Chicago and then he lived in Milwaukee, you could fly to Muskegon really cheap. Like, who lives there? Because all the other, Grand Rapids, Traverse City, they're all so much.
Which is probably going away.
And Muskegon was so inexpensive.
Yeah, and you bring up a great point. So in several of the airports in Michigan, they have EAS, which is called Essential Air Service, which is a subsidy provided to the airlines to provide service into these airports. Pelston is a great example. That, and now that's on the chopping block with the folks in Washington too. Now, before you go, I wanted to also point out to you, you'll probably look at me and say, well, now we're never gonna think this guy's sane anymore, because last fall, I actually went and worked in Antarctica.
Wow.
And you may have heard lately of a story just recently about a plane that went down there last week in the terrible conditions, because it's their winter right now, and went down there to rescue 3 people that needed more medical attention that they could provide down there. So for those that want to stick around a little bit and everything, I did want to let you know I've got several photos here if anybody wants to see them. But before we move on let's make sure we've covered all the questions on. Yes, ma'am.
So how many bounces?
How many what?
Bounces.
Basketball.
Oh,
That was the answer.
you know, I never counted. It's called I cheat because I got the video. Yes, ma'am.
I don't think that I'll get arrested because too many years have gone by, but back in the 70s, my friends and I would go to checkpoint 6 at Metro, and you'd get out of your car and then you would guess what plane is coming down which runway. Okay, so nobody told us we couldn't do that.
Security is way different nowadays. And I can tell you, you know, as you start talking about planes coming into Detroit, Detroit can actually, at this point in time, land 3 planes simultaneously on 3 different runways, having them all lined up, three lines coming into the airport. We call those triple simultaneous independent ILS operations. And right now, with the procedures that we have and everything, we can actually put down 128 aircraft per hour, plus get departures out of the airport. Kind of cool stuff. Yes, sir.
Are the oceans still uncontrolled?
Partially. And I'm gonna
Repeat the
say
question.
not,
Can you repeat the question?
are the oceans still uncontrolled? And how you generalize that is not necessarily correct. Ocean separation standards most of the time do not involve radar. They involve assigning chunks of airspace according to time. We call it non-radar control. So if you're leaving New York and you're going to Paris, at some point in time, you do not have radar coverage. You are reporting your position according to a certain preset plan of where you are and what altitude you are at and when you're going to cross the next point. And we separate you according to those. Now, out in the Gulf, in the ocean, with the technology that we have right now and everything, is a great example that we're using what we call ADS-B. And it's providing us with information that the plane is actually transmitting on its coordinates, on its altitude, who it is and everything. And we're have a display where we can actually see those planes and separate them with radar separation procedures. But the real long expanses of ocean are typically done with non-radar procedures still, and we're using high frequency radio band, which hits the atmosphere and bounces off, versus line of sight frequency management, where if you're below the horizon, you're so far out and everything that you're not gonna get the radio transmission. So going down to Antarctica, typically I handled planes that flew from Christchurch, New Zealand, down to the ice where we are, which was 2,400 miles. And I controlled actually from the 60th south parallel all the way down to the South Pole, up to 60,000 feet roughly. And we did all of that by just that type of control that I'm talking about, where you got a position report. And if you didn't get it on time, then you started implementing search and rescue procedures.
Well, I guess, so they don't use like, I mean, anybody can be looking at a flight radar 24 and look at any plane over the ocean rather than shoot a radar off of that, right?
If they are using the system, with the whole ADS-B thing and satellites now, there's a lot of stuff that's being run on the satellites, but a lot of it still is not where you could use it for radar separation. It's not as accurate as it needs to be over the ocean. What else we got?
This might seem like a silly question, but it is sincere. You mentioned there were worms on the runway, so many that you had to use like the equivalent of a snow scraper.
Yep.
What year was that and where was that again?
That was at Lansing, and it would have been sometime between 1989 and 1994 or so.
Has that ever happened again?
Don't know.
Know of? I mean, I just look, if I go walking or running around the street after a rain.
Uh-huh.
When I was a kid, you'd see tons of worms, tons. Now I'll go, I'll see 1, 2, or 3.
Keep in mind that
Soil degradation, I guess? Or-
well, keep in mind that the soils and everything, the wildlife, you have these wide expanses of grasslands and wetlands at airports that naturally, contribute to this stuff. And quite frankly, that's why you also have bird problems a lot of times, because it's like an open buffet.
Fascinating.
Thank you.
Does anybody want to see any other photos? Okay. So down at Antarctica, this is the base here, right here. It's called McMurdo Station. It's the main U.S. logistics base in Antarctica. Typically, during their summertime, which is like December, January timeframe, there could be 1,000 people stationed here, scientists moving in and out, support personnel, pilots, air traffic controllers. And you can see right here, fuel tanks, dorms, and this is McMurdo Sound in the Ross Sea. This is all sea ice right here, all the way to here. You can see those mountains over there, and that is the 2 airfields are actually out on the sea ice. And so you land on the ice out there. That's about 50 feet thick at that position. And here's the cool part, is the airport, the airfield, is moving 28 feet per month heading out towards open sea.
Moving target.
Yes. So you got that. And then you've got, this is the receiving area at Christchurch, New Zealand. This is where you're first walking into when you're reporting. I was on what's called a C-17. I'll show you a picture of it here shortly. But this is us flying down at the end of September. And we were actually flying with 3 different helicopters in the plane at the same time. It's kind of what do you call those, horizon shots, however. Anyway, there's me in front of 2 of them. Here's the cockpit as we were flying down there. There's the plane, C-17 right there. That's the military transport that's used most of the time now, besides the C-130. This is a view from our dorm, the little lounge that we had. And you can kind of see the snow drifting across the open sea here portion. And the funny thing about the snow down there, it's very dry. And so the snow that you got a week ago blows this way and creates drifts over here. And then the next day, the same snow blows this way and creates the drifts over here. And then it blows that way and creates the drifts over there. So it's basically the same snow all the time.
What was the air temperature?
When I landed, it was 37 below 0 Fahrenheit. With about a 40 knot wind. Chilly.
Wow.
This was one of the places that I worked. This is operations. And we typically control the airspace above from this building. And here's one of the signs for McMurdo. And then right next to us was the base for New Zealand, and that was called Scott Base. And when you first get to New Zealand, they issue you all kinds of winter gear, extreme cold weather gear and everything. And so this jacket that you're issued was made by a company called Goose, something or other, out of Canada. Canada Goose, thank you. Absolutely the warmest jacket you'll ever wear in your entire life, but they're like $1,700. But I'll tell you what, you didn't want to be without one. Here's a closer look as we're starting to look into the compounds. Here's dormitories. Here's one under construction. This blue building here was where the cafeteria was and all, like, we'll say, employee services. They had an ATM machine, stuff like that. Again, that's the C-17. Here's some of the other aircraft that we used down there. These were what we call Basslers. And this was the old vintage style DC-3s that you used to see. And what they've done is they've ripped off the old engines and put turboprops on them and re-outfitted them. And then these are called Twin Otters. And all these come from a service in Canada called Ken Boric Air. They fly them down there every year and then use them all season and then fly them back. There's the C-130s. This unit here, if you'll notice, there's actually skis on the bottom of these planes. And these are out of the Air National Guard unit in Schenectady, New York. That come down there to help the mission every season.
And they're parked that close together on 50 feet of ice?
Uh-huh. Oh, yeah.
Ron,
Yes, sir.
the library is closing up within the next couple of minutes.
Okay.
I want to thank you, and you helped us understand what you've done and what the work is, and I think we all have a much better understanding and appreciation.
Sounds good. Thanks, everyone.
All right. Thank you.
Good.
Much appreciated.
Thank you.
I saw your face at the post office, lady. They've renamed, renumbered them, redone so many things. So I personally have never done anything at checkpoint 6.